Let's try example number 3. Find a, let's pay attention to this, general solution. So there's no function in here, there's no y equals f of x, which means we do not need to solve for y at the end. So that's nice. Find a general solution of this. So first step, I need to get all the y's on one side and all the x's on the other side. So let's start by multiplying everything by dx, just to get it out of the denominator. So I've got dx, actually let's read y minus 2 dx equals x dy. Now, I've got those separated, but my x's are with my y's, and my y's are with my x's. This is all gross. So now, let's do this. Let's multiply this one by 1 over x. So now, I have 1 over x dx. So now my x's are together. And multiply this one by 1 over y minus 2. And now I have my y's together. So let's check x's and dx's on one side, y's and dy's on the other. That means I'm good to integrate. Okay, I want you to pause the video, try doing the integration on both sides on your own, and then come back and see how you did. Okay, here's what I got. Now, one note, I can choose to put this plus c over here with the y or over here with the x. You kind of get to choose that. I would say it's a good general rule to always put your plus c with your x's. It will make your future steps easier if you have any steps coming next. So that's what I would do. Keep your c with your x. Now, to kind of see an example of why this is easier, let's say this problem did ask for a function or y equals f of x. So let's go through and talk about how we would solve this problem if we needed to solve for y. Now, if I needed to solve this for y, I would start by doing everything e to the left side, e to the right side. Now, I do this because e and ln cancel each other out. So I get y minus 2 equals, now this, I can't just cancel both of those out yet because of this plus c. However, I can do a rule that we've done in the past backwards. Because we've said if we're multiplying two things, then we can add the exponent. Well, that's the exponent added. So I can do that rule backwards and end up with this. So essentially what I'm saying, this is the same thing as that thing. And then instead of saying this is e to the c, I'm actually just going to change that to one big C. And that e to the ln cancels, so that e to the c turns into one big C. And then I'm left with x. And then I can add 2 to solve for y. So if it asked me to solve for y, that would be my answer. Okay, let's do our last example for this video. It says, find a particular solution if y of 1 equals 1/2. This is a solve for plus c. That's what that means. So I'm going to take my particular solution, y equals cx plus 2, and now I need to plug that in to solve for c. So y is 1/2, x is 1, so I minus 2, and I get c is -3/2. So my particular solution would be that. And there you go. That's all for this video. In the next video, we're going to talk about using solutions to plug them in and see which one works.